Okay, so let's talk a little bit about different types of resistors. Look over here, there's two main types of resistors that we're going to be talking about. The first one is a fixed type, and the other is a variable. So let's talk about the fixed type. You're going to see these sorts of resistors in your kits. And these resistors are a fixed type. And they have a series of colors on them, and the colors we'll get to in the next lecture. The colors denote the value of the resistors, because the resistors, as you can see in your kit, are very, very small. And in order to be able to see the value of resistance, they have to use color codes, and then we translate those color codes to numerical values, because some of the resistors can be fractional and some of them can be very large. So the first type of resistor I want to talk about is the fixed type. So the fixed type resistors, the most common type of fixed type resistor is called the carbon composition. That's what you're seeing here. These are the carbon composition. And the carbon composition type are made from a paste that consists of carbon, obviously, and a filler material. Some of them use like a cermet mixture, which is a fine glass particle. And what they do is they take this paste material and it's mixed up in a slurry. And what they do is they form it onto a non-conductive material, and then they put these conductive rods on there as well, one on either side. What happens as the electricity runs through this here, as the current runs through this, it starts resisting that current, and that resistance starts to build up, and it gets dissipated as heat, and heat is an energy loss. So as we start putting resistance into circuits, we start getting an energy loss. That energy loss is translated again in heat. It dissipates in heat. The problem with these types of resistors, or any types of resistors, is if you put too much current through them, then they only have a certain wattage capability. So if you put too much current through them, then they'll get too hot and they'll burn up. Some of them will smoke. Some of them will catch fire for a little bit, and then they'll actually burn open, meaning open that they won't be able to conduct any more current. The carbon composition resistors are the least expensive on the market. They're very, very inexpensive, just for pennies a piece. They do have certain limitations, again, in terms of their current, so they can't handle a lot of current. They typically will go up to about 2 watts, so fractional values of wattage, 1/8 of a watt up to sort of 2 watts. Now, having said that, if we take a look at a resistor that is perhaps this size, and let's call that resistor 100 watts, and if I have another resistor beside it that is perhaps bigger, but it's also rated for 100, I said watts, but I meant ohms, has 100 ohms, and perhaps this is a half watt resistor, and perhaps this is a 2 watt resistor. So they'll both have the same ohmic value, the ohmic value being the value that is the nominal value that is being manufactured to, that specification that is being manufactured to. So they both are good for 100 ohms. They will both have a voltage drop across them that are the same, given the same voltage or pressure. The only difference here is that, well, one, as you can see, is larger than the other one. And you can see that the larger one is a 2 watt one. And the reason for that is because as resistance resists current in the circuit, as it resists current, it develops heat. And if it's physically larger, I have all this area here. If it's physically larger than this one here, then it has a greater ability to dissipate heat. It acts as a heat sink. It allows the more air to be able to get to the resistor itself. So the larger it is, the larger the wattage it is. So when you're looking through your kits and you see very small resistors, they are very small value of wattage, whereas the larger resistors are larger value of resistance. The other problem with the carbon resistors, now these were the most widely used resistors in industry up until film type were developed. But the carbon composition resistors, so they can't handle a lot of current, but the other thing is that they vary in their tolerance value. And you can see this tolerance. This band here actually denotes a tolerance, and we'll get into that. But the carbon composition resistors will have tolerances between 5 to 20%. And what that means is that if a resistor is manufactured to be tolerant to 20%, for example, if we use this one here, I said, okay, well, if this was a 20% tolerance, then what that essentially means is that this resistor will be manufactured to be within 20% of this 100 ohm range. So it could be as low as 80, it could be as 120. So the range is very, very large. Now a smaller range, say 5%, let's say this one was 5% over here, then the range would be between 95 and 105. So more of a precise type of resistor. So the tolerance really does lead to the quality of the resistor. A resistor that has a 20% tolerance, not very good. A resistor that has a 5% tolerance, much better than a 20% tolerance resistor. The other problem with resistors, carbon type composition resistors, is that as they age and as they resist current over their lifetime, as they age, they start to increase their value of resistance. So a resistor that may have been 100 ohms 10 years ago may be 120 ohms or 130 ohms. So it increases its resistance as it ages, which is better than it decreasing its resistance as it ages. Okay, next type is a film type. So this one here, and the film type is has taken over for carbon composition. It's much more precise, and there's a resistance film that's deposited on this non-conductive rod over here, and then the value of the resistance is actually set by cutting a spiral groove through the film, as you can see right here, the spiral groove. So the resistance is a function of both the type of material, the metal material that they're using, but also the value of the groove, the depth, and the width of the groove that they're putting within this resistive film. So the length and the width of the groove determines the resistance value, as well as the type of material that they're using for that. And you can see it's got a variety of protective coatings, metal film inside, a ceramic carrier there. And there are a couple different types. There's carbon film and there's metal film. I'm not going to get into that. We'll talk about that more in detail in a lecture. They are more precise, and they are relatively low cost, and they do have a tolerance. Their tolerance is between 1 to 2%. So as you can see, it's much better than the 20% over here. Okay. This is a chip type resistor, and you can see there's a variety of different chip type resistors, and they'll have all numbers on them to denote what type of resistance value they have. They're basically tiny ceramic blocks shaped resistors, and they have a thick carbon film that's deposited on the ceramic chip. The power dissipation in these are typically about 1/8 of a watt to 1/4 of a watt. So they're not meant for high current applications. However, they are nice in that they're very, very small. The tolerance on these are between about 1% to 5%. But again, they're specifically made for electronics. They can house multiple resistor and multiple different resistant values within them. And they are ideal for electronics in a crowded circuit board. The other type is wire wound. And wire wound is this one over here. And in the next video, I'm going to talk about wire wound and variable type potentiometers and rheostat. So for that video, you're just going to look for the next in this series of videos. So that would be resistors 2.